As we have already seen in the Feature of the Week video number 68, the MonolixSuite comes with an API for R that allows to use Monolix and PKanalix from R, which means that all you can do with the interface can be done with the API. You can check this previous video for information on installing the API implemented in the package Lixsoft Connectors, or for some examples on using it for Monolix. In this video, I am now going to show some examples for PKanalix, the application of the MonolixSuite for non-compartmental analysis and compartmental analysis. I have written here an R script with some instructions for PKanalix. This script is going to create a new PKanalix project to perform non-compartmental analysis on this PK dataset. I have opened it in RStudio. As I mentioned in the previous video, RStudio is not mandatory, but is a convenient environment for R programming. I will first set the working directory to the source file location, which is this folder. And I am now going to explain this script in details. The first line loads the package Lixsoft Connectors, and the second line initializes it with PKanalix. This command reads the path to the installation of PKanalix from this file and checks that the path is correct. In that case, it indicates the version of PKanalix that will be used. Next, I create a new PKanalix project based on this PK dataset with the function new project of the Lixsoft connectors. This is similar to creating a new Monolix project, except that I don't have to provide a model, only the data with the path to the data file and a list of keywords indicating how to use each column of the dataset. Let me open the file here. It has 7 columns, therefore I give 7 keywords characterizing each column. The first column ID contains the subject ID. The second column time contains both dosing times and measurement times. Each line contains either a dose amount in the column amount and a dot in the column counts, or a dot in the column amount and a PK measurement in the column counts. These two columns are marked as amount and observation columns for PKanalix. Some PK measurements are below the limit of quantification. In that case, the corresponding line is marked with a 1 in the column BLQ, and the value in counts is actually the level of quantification. In the script, the column BLQ is indicated with the keyword sense. In this study, each individual has received either a reference or test formulation, and this is recorded in the column form, which is used as a categorical covariate in PKanalix with the keyword catcov. Finally, there is a column study in my dataset which has the same value for all lines. Since it is not useful, I am going to ignore it with the keyword ignore. After creating the project, I can change some settings from their default values for the NCA task, such as the integral method or the way to handle censored values before Tmax, with the function setNCA_settings. I then save the project with this name with Save Project. Finally, I run the NCA with Run SCA Estimation. This function creates a result folder next to the project with all the NCA parameters computed on the dataset. I read the results for AUC infbred and Cmax in the table indifparams with the function getNCA individual parameters. With this command, I now print the first rows of indifparams. We can see that it contains also the IDs and the covariate values from the dataset. This table can thus be easily used in R for post-processing or plotting of the results. For example, I can use the package table1 to create, with just a few lines, a nicely formatted summary table for the results split by formulations. PKanalix can also perform compartmental analysis, which I can of course also run in R as shown in the next 3 lines. First, I set a structural model from the PK library by giving the file name. Here, the file corresponds to a one-compartment model with first-order oral absorption and linear elimination. Then I run the compartmental analysis with run CA estimation. The function getCA individual parameters can then be used to retrieve all individual parameters as well as a summary, which I print here. Note that in addition to creating a new PKanalix project, I can also load an existing project in R. For example, in this folder, I have a project nca-remi-sd.pkx for which I have already run the NCA and the results are stored in the result folder nca-remi-sd. In this script, I load the project with the function loadProject and the path to the project file. I can then use the function getNCA individual parameters to read the PK parameters from the result folder without running again the NCA. And I print the first rows with this command. That's it for this video. You can find all available functions of Lixoft connectors for PKanalix on our online documentation. See you next week.